My name is Mark Davies. I'm currently contracted to the IOGP, which is the International Association of Oil and Gas Producers, as a technical consultant. Prior to this, I had more than 9 years experience working for high-pressure water mist manufacturers. For the IOGP project on the procurement of water mist, I was the lead subject matter expert for the work group, and in collaboration with the water mist manufacturers around the world, we helped deliver this package. So hopefully you can all see my screen. So the agenda for today is an introduction to IOGP and JIP 33, a brief explanation. We're talking in more detail of Project 719, which is the water mist project, whilst covering an area called digitalization, explaining the software that was used in delivering this project. We have a small case study by one of the water mist manufacturers showing the potential benefits of this project and what happens next. JIP 33 was a collaboration between IOGP and the World Economic Forum. The idea was to help standardize the procurement specification. We're looking at the essential needs and the requirements to lead towards smaller inventories and shorter lead times. But one thing was relevant right from the beginning is that options and choices were still needed for the various projects. The objective of this is to improve efficiency and reduce risk of cost and schedule overruns. Quite simply, JIP 33 adds value by making the supply chain faster and more efficient. And this is not only beneficial to the purchaser, I think this is beneficial to the water mist supplier. JIP 33 consists of the 12 committed sponsors that you see at the top of the page, instantly recognizable around the world. These are known as throughout the presentation as the operators, so a key part in this project. JIP 33 has more than 20 working groups delivering and upgrading existing specifications, where we work with the suppliers and the standard development organizations such as API, IEC, BSI, etc. There are more than 300 subject matter experts coming together from the above 12 companies, sharing knowledge, insights, and expertise. To date, there are 40 publications that have been published and over 39,000 downloads since the inception in 2018. JIP 33 has been delivered or is being delivered from centres in London and Houston, and despite the emergence of COVID in the last year or so, the project has continued remotely. New for this year and last year is we have a contractor group made up of the EPC partners. And also we're looking to have more case studies proving the success of the project. So why did we want JIP 33? If you look on the screen here, we can have before JIP 33. So what we have is we have 3 projects, all for a water mist system. One is from an EPC and 2 are from the operators themselves. Now, specifications, and this is true for pretty much every product that is purchased for this sector, it's based on what we call a parent standard. And in this instance, water mist systems are NFPA 750. So we have the parent standard below. What we were finding is that depending on the operator, the project, the engineer, the amount of additional requirements, the specifications, would vary greatly. So there was very many different designs for the customers. The suppliers would have to increase their inventory to accommodate all the options. And obviously with the variations, there's more documentation, paperwork, and inspections. So going forward, below the line, nothing has changed. We still make reference to the NFPA 750. However, there is now a commonized set of additional JIP 33 requirements. So this is a technical requirement specification. So this is an overlay to the parent standard, NFPA 750. a set of information requirements, such as documentations, general arrangements, reports, certification, procedures. And we also have the quality requirements, such as inspection intervention points. So again, hydrostatic test, pneumatic test, nozzle K-factor flow tests, etc. Whilst maintaining the option for selected projects. So we appreciate that a platform in the North Sea can have completely different requirements to a product that would be based in the deserts of Saudi Arabia. So we still have the options and the opportunity to customize the project. I was trying to think of a single image that would help represent this in one go. And I think the one that was the most universal is the color chart, RAL 3000, 3001, 3002, 3003. Water mist systems can be and have historically in the past been supplied in all of these colors. The question you need to add is, what value does this add to the product? I would say 0. It means for the supplier, they would need to potentially stock 4 paint colors. They would also need to have 4 purchase orders. So straight away, this is adding cost. And whilst this is a very small, very minor part of the system, when you see the scale of the project, and if this was to happen on every project, you can see where there are potential massive savings to be made. So to date, we have 40 specifications that have been published, and in ways these work together. So we see the water mist one here as 719. If we look downstream to this, we have the potential of couplings connecting the pumps to the motors. We have the potential of the electric motors themselves. We have the potential of welding. We also have coating and painting procedures, etc., which may and could have an impact on our specification. Going upstream, we also have the ability to have water mist included within the transformers and other specs that have yet to be published, such as diesel generators. So we're building together. So the one small requirement, whilst on its own, about the color being RAL 3001, for example, is only small, but when you multiply it by all these potential projects, and that is one requirement, you can see that the advantages are amazing. So the water mist project. This was a collaboration across the globe. We've mentioned earlier the 12 supporting operators that were involved. And at the beginning, we evaluated more than 18 water mist suppliers from around the world. This was based on the water mist suppliers' listings and approvals relevant to this sector. We reached out over nearly 2 years ago when the project first started to 12 operators, and we actively engaged with 6. So we have a water mist manufacturer in the USA, we have one in Australia, along with the 4 in Europe that formed part of our team. So the first step of the project is to frame what we're going to do as a work group. So we come together as a work group, we take a subject matter expert from each of the operators mentioned, and we define what the project will be. So the first step was the scope. It was important that we included all pressures, low pressure, intermediate pressure, and high pressure. We didn't want to exclude any particular application of water mist. It was essential that we limited the specification to listed and approved systems and those that could be accepted through a fire engineered approach. There were exclusions, and one of the exclusions was for blast protection. At this moment in time, 1 or 2 of the water mist manufacturers were investigating this, but we didn't think that it had matured enough for inclusion into this specification at this stage. The benefits, along with standardization, there was also design resources. We felt that the design of the water mist system could be taken more away from the purchaser and the EPC and pushed on to the design authority, which is the water mist supplier. this is their bread and butter, their core product. They work this 24/7. They know this technology far greater than others within the oil and gas sector. The other intervention, the other benefits were the reduction of interventions. We'll talk more about that later on. This is quality interventions, the inspections, and the great advantage was fire engineered solutions. So where there were applications where fire test protocols do not currently exist, such as lithium-ion transformers and applications exceeding current design fire protocols. There were issues. There are risks to this project. At the time, EN 14972 was still in draft format and was not an approved documentation. The other risk is potentially volumes and fuel loads. Whilst we appreciate that the standards such as FM 5560 relate mainly to diesel and heptane, there are other fuels used within the sector, and also the volumes. The approvals are limited to 260 or above 30. So areas outside the approval system. We looked at what supporting specifications could be involved in our project. So we spoke about some earlier, the coating, the painting, bolting, motors, etc. We considered those. So we then looked to what would be the parent standard. So we reviewed all the standards that we know, FM, IMO, UL, VDS, British standards, etc. However, the clear choice was NFPA 750 as the overlay. External suppliers, like I said earlier, we contacted 12 suppliers hoping for their input. We got 6. And part of the risk we noted is that we felt that the experience of the work group was relatively low on water mist, and we could learn from that. So knowledge was a potential risk. The parent standard was a potential risk, and we also had to highlight the fact that we weren't sure if the suppliers would come on board. So when we come to develop these projects, we used a tool called JIPMA. So the main output is 4 documents: the technical requirements, which is an overlay to NFPA 750, the quality requirements, information requirements, and the data sheet. So this is an online application that brings everything together. So we can see here in the water mist project, and those that are keen and familiar with NFPA 750 will see that we have structured this to represent every clause within the parent standard. So we went through collectively as a work group, doing a gap analysis on every single individual requirement within the parent specification. So when we do the gap analysis, we're looking at the type of gap, we're looking at the actual requirement that we're going to add in, but most importantly is we must have a justification. We could no longer accept, we always do it this way, we've always done it this way. That's no longer a justification for having a requirement. Every time we add a requirement, whether it's in the overlay, the quality requirement or information requirement, that equals a cost. So whether we want a document, that potentially equals a cost. If we want an inspection point, that equals a cost. So once we've justified our requirement, we need to verify it. So we explain how we would run a check against this and what coverage is needed. So if we're looking to make a dimensional inspection, we would obviously need to cross-reference something like such as a general arrangement or a component drawing. So within the software, we can link that one individual requirement. In this instance, we made an addition to section 5.2.2 of NFPA 750. And what we have here is how is this connected? What is the relationships to other documents? So we've added an additional requirement, item number 9. And so we've linked this to approved systems, to the design manual. So it's important that the design manual reflects the system that we're procuring. We're looking for the approval, whether it's a listed system from FM or the VD, for etc., or if it's a fire engineered solution. We're also looking for where this is chosen in the data sheet as well. So we've got a document link, a quality link, and also a data sheet link to this. Within this software, we can record comments. So the workflow would typically be that the LSME would write the requirement and the justification, and using the tool, the peers in the group, the core team and the work group would use the reviewing feature to make comments against it. So in the future, when we come to revise this document, we have the full history of all the conversations that went on to make this one requirement. We also have the ability to transition and track the status. So everything starts in a draft format. We can work through the 7 or 8 steps leading to a full published specification. The other tool we used for digitization was a QV Scribe. So this is checking the quality of a requirement. And a requirement should be short, concise, and has one imperative. For example, shall. It must be very clear. The goal of this is to have a common understanding, so there's no open to interpretation. So it works on a very simple scoring system. And as an engineer, prior to this project, the statement here is hydraulic chambers should have 2 ports located at extreme ends to allow efficient flushing. This seems quite reasonable. Those who are sharper-eyed have noticed there's some words there in bold, should. Well, if you're as you're a supplier of a water mist system and you see this as a requirement, should means, well, it's not necessarily essential, so I'll skip that. 2 ports located at extreme ends. Extreme ends. What happens if you have a product where your ports are not located at extreme ends? So one in the middle, one at the extreme end. So you're ruling out the opportunity for innovation, and also to allow for efficient flushing. Efficient is vague. You cannot quantify what's efficient. My version of efficient may be different to others. So using the tool, the simplified requirement is hydraulic chambers shall. That's a requirement. That's what we need. So that's a check. We would then be able to link this, for example, to a possible inspection that we check that there are 2 flushing ports, and also link to a general arrangement drawing to accept this. So this is a great tool that was used and is used on all projects. So we spoke earlier that we're talking about the 4 documents, the technical requirements, data sheet, quality, and information requirements that are all based on top of NFPA 750. The data sheet is for procurement only, so it's to give immediate information from the purchaser to the water mist manufacturer on the ease of procuring the system. Information requirements, as I've touched on, covers such things as the DIOM, hydrostatic test certificates, etc. And QRS is the quality interventions that are needed by the purchaser. So if we look at a data sheet, and there's a couple of examples of how they're configured now. It's currently in an Excel export, where there's a color-coded system depending on who fills in the data. So some of the information's from the purchaser, some is from the supplier, and some come from Eva. Where possible, we've got to select from a drop-down list. So in this instance, we're looking at the location. And what we've done is the terminology and the guidance. So where you see the red triangle in the corner, there's a set of guidance instructions on how to use this document and what information is needed. So the terminology used is one that was agreed between the oil and gas sector and also the water mist community. So it was common language used throughout, and wherever possible, we defaulted to the parent standard, so the terminology used in NFPA 750. Quality requirements is one of the key areas where we can reduce cost and delay. So CAS levels is a conformity assessment system. This is determined by the purchaser. So if you're a supplier D, so you're potentially known as a supplier that is, let's say, gold standard, you're a proven supplier, you commonly supply to this manufacturer, this purchaser, you'll see that by the color visualization here, that green can represent no participation. with, for example, the operator would assume that we've used that supplier many times in the past. We don't need to keep seeing this information. So no interventions required. And we gradually build our way up. So if we looked at the CAS A, this could be a brand new supplier or a brand new technology. There may be an innovation in water mist, a new application that's not covered by existing fire test protocols. You know, we still want to use our existing one, but we're going to have more interventions, more activities due to the complexity of the project. So the supplier will be classed as A, B, C, or D, and it will be depending. The supplier may be a CAS D with one operator, but only a CAS B or a C with another operator. So it gives the opportunity. The other key thing is here is when we produce this document, you have links here relating back to NFPA 750 and also the overlay to see why you're actually requiring this pneumatic test, why you're requiring the hydrostatic test. And I feel this is a very useful tool to look for these requirements. Information requirements, again, a spreadsheet listing the typical documents that may be needed in a project. What we do have is we have the ability to be able to ask for certain documents depending on the supplier's CAS level. So for example, if you're a supplier that we've never used before, we'd like to see the flexible hose test certificate. If you're our preferred supplier, our approved supplier, that is one piece of document we no longer need because we understand this is part of your type approval and we don't need to see that document. So you start reducing straight away the number of documents needed to be submitted. So again, a cost reduction and a delay, time reduction. So after the full documents were processed, we had a full work group of 12 operators and we agreed the full documents. So to give you an overview, there was over 900 requirements in NFPA 750 that were untouched, unmodified by the work group. We added 68 additional requirements. The data sheet exists 179 line items, 36 quality requirements, and 64 information requirements. So the next phase is a 4-week public review where, as it says, we go out to everybody. So this goes to the operators, the suppliers who are involved. It's pitched on LinkedIn. It's put out so anybody in the public domain can comment on the documentation. So again, it's all managed in JIWMA. We can clearly see against each clause where there's comments, where there's acceptance, and where there's rejection. And again, the comments are made here and they're logged. So they're not only logged for the first phase of the project, they're historically associated against that individual item in the digital database. So after we've had the public review, we go through the alignment phase. So we received 482 comments. 200 were against the technical requirements, but the key thing here is the 47 red flags. The red flags are items that have been raised by the water mist community and the operators that could potentially add cost or delay to the project. So we operated a triage system and we tiered the 482 comments based on the severity and the classification. So we addressed the primary focus was on the red flags, and then we worked our way through the all the other requirements and reviewed them. So all requirements reviewed and actions were justified. Once we've agreed, again, as a collective, as a work group in the alignment process, we go through the finalization for publication, where we go through technical writer checks and we go through justification paper, which includes 23 independent checks done on the documents before they're sent for publishing to the project director to sign off. So the 4 documents are sent out for voting to the 12 operators. And here we can see that the project was voted through. We look through for no rejections. If there's one rejection, we go back again and try and address it. We do have some comments for the future, some future amendments that we can consider for the next version. And we can also look at the data sheet in the IRS. So when we come to do the update of the documentation, we will consult back to this information that's stored within the database. So as we exist today, the publications, the specifications are free to download to anybody on the online library. And we'd like to invite the water mist community to work on this and use these specifications to give their feedback in the future. So we have a short case study done by Marioff where they looked at historically 5 projects in the past. So we have at the lower end the 5 projects. We took the baseline, or they took the baseline that the volume impact of the JIP 33 spec would be the baseline, the 100%. They felt that the Marioff standard was slightly above this on lead time. However, with volume production, assuming that all 12 operators procured to this spec, they could come down to this number. And when you look at the previous historical projects, you know, some were very close to this minimum requirement of our spec. However, some projects were extremely way off. But if I go back, what was noticed is there's potentially a 36% reduction available. When we look at the projects here, we can see that a lot of the additional costs and delays are related to items that are not necessarily part of what I would call the water mist system, the approved water mist system. They're the ancillaries that go to support and to make up the project. So what their conclusion was is that has a limited impact on the overall system due to type approvals. You know, a water mist system is limited on what you can use within it anyway. The main drivers are the instrumentation, the cables, wiring, and specific components like tubing and fittings. So going forward, we have the ability, the IOGP has the ability to track and to monitor the usage on the water mist webpage. And at the moment, we're currently seeing approximately 100 or so downloads of the documentation. Adoption. One of the key metrics that IOGP measures is the implementation of the specification. As of today, all 12 of the operators have indicated that they will have the intention to adopt this specification. We see that there's also at 30% they've issued, there's a few operators now that have issued a company standard to the library and ready to use. And we have one operator that has listed this in a project as a basis of design going forward. So this is good news. Unfortunately, with COVID and the slight downturn in the last year, the uptake is not there, but the manufacturers should be having visibility to this specification in the very near future. We would like more case studies from other water mist suppliers, if you have them, if you've got feedback on, and even if it's without data, if it could be based on historical data, that would be most welcome to help us support the case and to help us improve. Going forward, we also have plans for a maintenance and expansion of this project, most likely in 2023 when NFPA 750 is revised. We will also look to consider any advances in the technology made with water mist. So for example, lithium ion, transformers and that sort of thing. And also prior to that, we will go out for a public user feedback review. So we will be reaching out to the water mist community, looking for their feedback prior to us making any changes to the specification. And finally, I'd like to thank everybody involved in this project. It's a big collaboration from truly around the world. There was a lot of people involved. There's too many in the JIP 33 team to name individually, but this is very much a team project. And thank you.